Video 2 of 3 videos in total using and applying inverse trig functions. We looked at inverse sine in the previous video. This will follow the same pattern, just albeit a bit quicker that we followed in the previous video for inverse cos and inverse tan functions. So we looked at the idea in the previous video of sine, cos and tan being many is to 1 without a restriction on domain, and we have problems then when we take the inverse. So we need to restrict, need to make restrictions on the parent functions so that we end up with the avoidance of a situation where we have 1 is to many. In fact, firstly we're going to look at inverse cos, and we'll see that we restrict cos x to a 1 is to 1, so that when we take the inverse it is still a 1 is to 1 relationship. As we saw last time with y equals cos x, we reflect in the line y equals x, and we get we can see that red graph there, and that's not a function. So we have an issue as discussed in the previous couple of videos. Like we said with sine, there's actually an infinite number of different intervals we could choose or limit for limit y equals cos x to. The convention is to do the following: it's to go from 0 through to pi, and when we take the inverse of that, we get what we can confidently call a function. So every element of the domain is only mapping onto one element of the range, and no greater than that. So with y equals cos x here, we'll show the limitation. So from 0 to pi, and you can see that there in the black, overlaying the purple. So we'll remove the purple now, and we can see the inverse cos function here. Again, they're mirrored about y equals x, which you can see running diagonally along the graph there. So looking back at what we did, we restricted the domain on y equals cos x from here to here, and so that is that interval of the graph in pink. So that is a restriction on the domain, 0 to pi inclusive. So that's the domain for cos x, y equals cos x function. When you saw last time, when we do take the inverse, that will then be the range for the inverse cos. Now going back to y equals cos x, if we have that as our restricted domain, the corresponding range would be from -1 to 1. You can tell that numerically or by your knowledge of the cosine function, which you should have very well sorted by now. So that basically that range then is the domain for the inverse function, very much like we've been saying in the last couple of videos. Okay, so that domain -1 to 1. So we're looking at here okay, so we've got above the dotted line we've got 0 to pi and -1 to 1 for domain and range for cos x, as you know, and for inverse cos x we have now the opposite, they swap around, and so we've got a restricted domain of -1 to 1, and we've got a corresponding range of 0 to pi. So looking at that here, again we've got the black graph being the restricted cos x, and it goes from 0 through to pi for its restricted domain, and its range is from -1 up to 1, if you can see my cursor. And for the red graph, the inverse, we have the opposite So for inverse cos we have -1 to 1 for the domain, and we have 0 to pi for the range there, seeing pi there being a bit over 3, okay, 3 and a bit, and 0 down there. Now the tan graph is a bit more complicated, and it's got asymptotes, discontinuities and so on. So when we get to pi on 2, for example, when x is pi on 2 for y equals tan x, we get one discontinuity, and it behaves asymptotically either side of that discontinuity. So you can see that, and hopefully you're familiar with that. And then that process, or that phenomena I should say, happens again pi radians later at 3 pi on 2, and thereafter multiples of pi radians greater than or equal to basically starting at pi on 2. Okay, so we pi on 2 plus pi, or pi on 2 take pi, and you can see another one there at negative pi on 2 radians. You should be fairly familiar with that one. So again, the process of mirroring in the line y equals x produces those red lines that you see. Looking first at the graph again of y equals tan x, you can see there in blue, and I can put in a couple of the asymptotes there. Okay, and let's look at some of these features. So for y equals tan x, we look at the domain and the range for non-restricted y equals tan x. Now the domain's the easy part. The domain is the easy part because tan doesn't have domain limits 1 and -1 like sine and cos do. So its domain is all real numbers. And so when we look at the inverse of tan, its range does not have any restrictions. Whoops. Let me clarify that. I may have said the wrong thing. I've definitely written the wrong thing. So try that again, and I'll just make sure I've said the correct thing there. So the range for tan is all real numbers, because you can see that tan just keeps increasing, and especially as it approaches those discontinuities, those asymptotes there. So that means correspondingly for inverse tan, we have the domain is not restricted. It's all real numbers. So that makes it certainly different to sine and cos, inverse sine, inverse cos. You know that y equals tan x has basically a whole bunch of parallel branches, and they're separated essentially by the head of one is separated from the tail of another branch basically by the asymptote. So if we don't restrict the domain on y equals tan x, we'll get a problem when we look at the range for inverse tan x. So the convention is to choose this one here that we've talked about, that branch there, and through there. Now of course we have to miss these asymptotes, so we don't go up to x equals pi on 2, and we don't go down to x equals negative pi on 2. It's exclusive. So let's formulate that. The domain for y equals tan x is from negative pi on 2 up to pi on 2 exclusive. So you notice these are the curvy brackets there. Or you could say negative pi on 2 is less than x, which is less than pi on 2. Therefore, that implies that our range for inverse tan x is that same negative pi on 2 to pi on 2 exclusive Alright, so it's different in that it excludes, whereas the others for inverse sine and cos include. But as always, tan's just got to be different. So getting back to our graph, we've still got y equals tan x showing there with a green and a purple asymptote. And what we can do is show what happens when we put on inverse tan, and we have a look at what happens to those two asymptotes. Okay, and they essentially are transformed as well, so the inverse of those lines occurs as well. So you can see there, that's our restricted inverse tan x function. So it's continuous in terms that it has an unrestricted domain, but its range is between negative pi on 2, which is about negative 1.57, as you can see down in the bottom of your screen, and that corresponds with the black line there of 0.5 increments, and likewise in the positive direction there for the upper one. So the green line is the graph. So the next video is going to formulate an important inverse relationship for inverse sine, inverse cos and inverse tan, and that's going to be done by showing you not 10 but 11 examples.